Hey, so in this video, I'm going to explain how memory works inside of Solidity. A lot of programmers, a lot of developers, a lot of smart contract engineers work with Solidity, but don't actually understand what's going on behind the scenes. And you can work in Solidity perfectly fine without actually understanding what's going on behind the scenes, but you're going to be a much more competent engineer and a much more competent smart contract developer if you actually understand what is going on behind the scenes. Now, I'm not an expert on this topic, but I feel like I can give you guys some insights and some just knowledge on how it works behind the scenes, on how Solidity works behind the scenes. And for example, when we call in different functions, how do those arguments get passed onto the memory? How do they get stored in Solidity's memory? Okay, that's exactly what we're going to talk about in this video. And to do that, I've prepared a very simple smart contract, and we've got the license identifier up here as always, a Solidity version identifier in here. We're going to use version 0.8.19 and upwards. And then we've got the contract, which I've called variable length. We have got a struct here, which is going to be for demonstration purposes. I'm going to show you guys how structs are way more preferable to use inside of a function or inside of a contract in general. If we know beforehand, like before deploying the contract, if we know that the struct is never going to change in size, we are way better off using a struct instead of an array. Why? Because the array takes up way more memory space than the struct. Therefore, the struct is always going to be way more gas efficient, and it's going to cost less money when it comes to deploying the contract and interacting with the contract itself. And just so that you can see it very, very quickly, we're going to go a little bit deeper into it later. But this is the memory that we're using when we use an array, and this is the memory that we're using when we use a struct. So as you can see, the struct uses way less memory space, so it is way more efficient. Okay, and then we've got a bunch of functions. The 3args, which is just a function that takes a uint256, an array of uint256s, and another uint256 as arguments. 3args string, which takes, instead of a uint256 array, it takes an array of strings. 3args struct, which takes a struct instead of an array. Then 5args, which is a little bit of an overkill. I might go over it, I might not, because I think with the 3-argument function, it is super clear what is actually going on behind the scenes. The 1-argument function, which is going to be very useful when it comes to explaining you guys how this actually works, so you can see it very, very clearly. And then all variable, which we might not go over it, but it's just essentially a function that takes as arguments 3 uint256 arrays, which can be of variable length. Okay, so without further ado, let's actually get into it. And I'm going to start by explaining how memory works inside of Solidity. So memory inside of Solidity is basically laid out in 32 byte sequences. And if you've never worked with bytes or hexadecimal values before, or bits before, I really recommend you watch a video on how to work with bytes and the different conversions, like 1 byte equals 2 hex and it equals 8 bits. I recommend you get familiar with those sort of concepts before you watch this, because it'll be way easier. But basically, memory in Solidity is laid out as 32 byte sequences, okay, which is 64 hex. So if we copy this just to show you guys, and we open up our terminal and we run, I've done this before, but just to not spoil it for you guys, if we check the length of this string right here, it is 64, and if we divide 64 obviously by 2, it is 32 bytes. Okay, so 64 hex, because that is the way the Solidity stores in the memory, is 62 hexadecimal values, but it is 32 bytes. Okay, and as you can see, we have got many of these 32 byte sequences in memory. We have got the 0x00, 0x20, and this just go up in 32 byte increments. Okay, so the functions are going to take arguments. I mean, they might not take arguments, but then this video would be pointless if we wouldn't be doing it. So in the case of our functions, they take arguments because I want to show you how exactly they get stored in memory when we call the function. Okay, so we're going to start with the 1arg function because it is the easiest one to understand, in my opinion. So we're going to put it down a little bit, and we're going to save and compile the contract. Now, if you've never worked with Remix before, just make sure that your compiler is compatible with the version that you're using. So in my case, is anything that is above 0.8.19. In this case, is 0.8.34. So it's perfectly fine. It will compile. But for example, if I used a compiler version that is lower than 0.8.19, for example, 0.8.10, it will not compile. Okay, so just make sure that your compiler is actually okay to be used with the version of Solidity that you are using. Okay, so after we've compiled the contract, we need to basically select the contract that we want to deploy. In our case, it's going to be variable length because I don't have any more contracts in this Remix workspace, and we're going to deploy the smart contract. Now, once we've deployed the contract, we can select a function to interact with, and we're going to choose the one-arg function. If we have a look at the function, it takes a uint56 array as the argument. So we're going to pass a uint56 array, and it's going to be 1, 2, and 3 for simplicity. We're going to transact with this function, and what we want to copy is this call data here. Now we're going to copy the call data. Let's actually make some room for it, and let's paste it in here. Now this is a lot of numbers packed into this huge sort of string. I mean, it's not a string, but it's a bunch of numbers that probably don't even make sense to you at this time. But I'm going to do something real quick, and I'm going to split them so that we can see what is actually going on. Okay, so we're going to do that, we're going to do that, we're going to do that, and we're going to do that, and that should be it. And now I'm just going to comment all of this stuff out just so that it doesn't give us any errors. And I'm going to start explaining from here. So what is this? The first thing that we get back, and this is not stored in memory specifically, it's just something that comes with the call data. When you call the function, this gets returned, and it's just the function signature. Okay, if you don't know what the function signature is, it's basically the name of the function with the argument that it, or the arguments that it takes, and it is basically hashed. Okay, the catch-act256 function is run on the name of the function with the argument, and the thing that we're seeing here is the first 4 bytes of that function signature. Just to illustrate my point further, I've got a tool open up right here, which is very, very handy, and we're going to write the name of the function, which is one-arg, and then we're going to pass the uint56 array. Okay, now it is very important that you understand this. If we had, for example, 2 or more arguments, well, the first thing, you don't want to put the name of the argument. Okay, you don't want to write in here call data A. You do not want to do that when you want to check or you want to get the function signature back. That is the number one thing that you don't have to do. And then, for example, if you imagine we had another uint256 array, you don't want to use spaces. Okay, you do not want to use spaces because that will give you the wrong function signature. When we want to get the function signature, we don't need to use any spaces at all. Okay, but in this case we only have 1 argument, so that is completely fine. And as you can see, we count 1, 2, 3, and 4, and we're going to copy this just to illustrate the point. And remember, I'm counting bytes, I'm not counting characters, I'm counting bytes. And there you go, we have got the function signature, and we just add the 0x because it is in hexadecimal. Okay, and it is the exact same number as you can, or the exact same sequence as you can check in here. All right, now what are all these numbers in here? Well, like I said, these are called memory, like 32 byte sequences, but they're also called memory words. Okay, and the first memory word, as you can see, is all zeros followed by a 20. And when we're working with arrays, we're going to get given a pointer to the word where the array's length is stored. Okay, so this is going to be the pointer to the memory word where the array's length is stored. And if you recall from this function up here, or from this example up here, the first memory word is 0x00. The second one is 0x20. And if we go back here, we can see the 20. Now, secretly, you could get rid of all these zeros in here, and this would be like 0x20. Okay, but this is basically telling you that the pointer is pointing at memory word 0x20, which is this one right here. And in here we have got the length of the array, which is 3. Okay, so in here we have got the length of array, which is 3. And in here, straight after the length of the array, we have got the values. So 1, 2, and 3. Now, if you remember over here, we call the one-arg function with the u into 56's 1, 2, and 3. And this is basically array of 0. Whoops. Array of 0. And the next one is going to be array of 1. And this one is going to be array of 2. Okay, so first index, second index, and third index right there. So, I mean, hopefully that was pretty straightforward. It is not complicated at all. And that is essentially how Solidity stores things in memory when we pass it, or when we pass the array as an argument and as call data inside of a function. Okay, so this is the same example. So I'm just going to delete this just to have less clutter on my screen. There you go. And we're going to see how it works with structs, okay? Because with structs, like I said earlier, it is way more efficient, okay? Why? Because we do not have pointers. Structs get stored directly inside of memory. We don't have pointers, we don't have the length of the struct. Why? Because it is not needed to know the length of the struct, because if we're using a struct, we're not going to modify that struct, or the length of that struct once the contract is deployed is not going to be modified, because basically you cannot modify a smart contract. Okay, so we're going to have a look at this example right here. We are calling 3args struct. So we're going to, instead of interacting with this one-arg function, we're going to interact with 3args struct. And this function gets passed a u into 56, which is going to be 1, a struct, which is going to be 2, 3, and 4, and another u into 56, which is going to be 5. And we can just transact with this function like we did earlier. We're going to copy the call data, we're going to paste it in here, and like before, I'm just going to split this into more readable stuff so we can actually have a look at it. And there you go. And I'm just gonna comment all of this stuff out so we don't get an error. I'm actually going to get rid of this because it is the exact same thing. And as you can see here, I have got some annotations. Working with structs is way more gas efficient because we use less memory space. Okay, arrays have to store a pointer, the length, and the array values, while structs store just the values, making it more efficient. And we're going to see how that works right now. And just to illustrate the point that I was making earlier and make it super clear, we're going to check the function signature for this specific function. So we have got more than one argument, so we're going to copy this. And as you can see, if we did it like this, it wouldn't work at all. Okay, it doesn't work. Like if you can, I'm going to copy this first 8 characters, which would be the first 4 bytes, and as you guys can see here, it does not match. Okay, it doesn't match the function signature because we do not want to use spaces, we do not want to use the names of the basically of the arguments that we're passing. We just want to use the types. Okay, so remember, we don't want spaces and we don't want the names. I'm going to take the time to explain something that is very important. When we're working with structs, we do not want to pass the name of the struct because that will not work, but we want to pass what's inside of the struct, or what we've defined inside of the struct. In this case, it's going to be 3 u into 56s. Again, no spaces, u into 56 to 56 to 56. And now if we grab the first 8 characters, there you go, which is the first 4 bytes, we can see, where is it? There you go, it's right here. We can actually see that it matches perfectly. Okay, so now we have got the actual function signature, and we've done it with 3 arguments and with a struct. Okay, so perfect, that works, awesome. Just wanted to illustrate that point a little bit further. But now we're going to see what actually gets stored in memory when we use a struct versus when we use an array. Okay, so if you remember, when we used an array, we were storing in memory a pointer to the memory word or the space in memory where the length of the array was being stored, and then after the array's length storage in memory, we had the actual values of the array. But with structs, none of that happens. The first value that we have, so in the memory, in the first memory word 0x00, is the first argument. Okay, so the u into 56 first, let's call it first arg. Here we have got the struct. Okay, so as you can see, we don't have a pointer, we don't have the length of the struct, because it wouldn't make sense. Okay, it is way more efficient, and we've got the first value that we passed as the first u into 56 inside of the struct, which in this case was 2. So this is the first struct u into 56. This is the second, okay, second, and this is the third. And this is just the last argument, okay? This is the number 5 that we passed here, the row first in there. There you go. So as you can see, structs use way less memory than arrays, and therefore they are way more efficient when it comes to working with them inside of contracts. When you deploy the contract, like I said, when you interact with the functions, if you can use structs, it is always preferred over arrays. Okay, so that was it. I mean, I don't think it's necessary for me to go over another function, because at the end of the day, it's always the same stuff. So takeaway from the video: Solidity uses 32 byte sequences to store things in memory. And if you have to take away something from this video, I hope you kind of managed to understand how memory works. I know there is way more to explain about memory and how memory works and how things get stored in memory, but I believe this may have given you a little bit of an overview of how memory works in Solidity. That when you can, it's always more preferable to use structs instead of arrays, because you will use less gas, and therefore the deployment and the interactions with the smart contract will be way cheaper and way more efficient. And that is basically it. I hope you've enjoyed the video. If you've got any questions, just let me know down below and I'll try to answer them to the best of my ability. And if you don't have any questions, great, that means I've done a great job. But anyway, I will see you in the next one. See you soon.